And welcome to another 5-minute video for the Level 3 Technical Certificate. Today we're going to be talking about van der Waals forces. These are forces down at the atomic level, so they're quite difficult to picture sometimes. So van der Waals collected ideas from 3 separate people on 3 different types of force, so collectively they were all known as van der Waals forces. In this video we'll look at the 3 individual forces that have been defined. So van der Waals forces are forces of attraction. The first force of attraction that was observed by Keesom, so they're known as Keesom forces. The second type of force was observed by Debye, so they are Debye forces. And the third type of force that was observed was done by London, so they're known as London forces. So we'll talk briefly through each of these. So first of all, let's start with Keesom forces. Keesom forces are all to do with permanent dipoles. So if you imagine a molecule like hydrochloric acid, hydrogen chloride, then because of the electronegativity of the chlorine, most of the electrons hang around the chlorine most of the time. Therefore, this side of the molecule is always negative relative to that side of the molecule. That makes it a permanent dipole. One bit's always more negative than the other. And because these things are positive and negative, that will then attract positive and negative side there. And we've also represented it in terms of colour. So where we've got a large concentration of electrons, we make it pinkish. Where we've got a deficit of electrons, we've made it blue, just for illustrating dipoles in these couple of subsequent slides. So now we come on to Debye forces. Debye forces are all about induced dipoles rather than permanent dipoles. So here we've got our coloured sphere again. Just imagine hydrogen chloride. Hydrogen chloride is a permanent dipole. So one side is always positive, one side is always negative relative to each other. So if you have a lot of electrons here, when you have another molecule next to it consisting of at least 2 atoms, the side of the molecule that's nearest all those negative electrons, that will tend to push the electrons away because same charges repel. So what will happen is, there we've got this congregation of electrons that will discourage electrons from coming over here, and so it will induce a dipole in this molecule. And then the third type of dipole is identified by London, is known as the oscillating dipole. And I've tried to represent this here. So there we have a whole selection of molecules where the dipole is one way, and then a moment later it will switch and it will go the opposite way, and then it will switch back, and then it will switch back again. So so 1 minute one end of the molecule is very positive and the other end is negative, then they'll switch around. That'll be positive, that'll be negative, then it will switch around again. So we've got induced dipoles, and those induced dipoles will be attractive to the induced dipole next to it. So, summary. Van der Waals forces, it's all about forces of attraction, and there are 3 different types of dipole that will encourage attraction. You've got Keesom forces, where we have permanent dipoles. We have Debye forces, where we have induced dipoles. And finally we have London forces, where we have oscillating dipoles. So a bit confusing that can be. Watch it again if you think it will be useful. And thank you for listening to this video, and please feel free to follow us on any of this social media.